Hey guys, I'm going to go through and just talk about each question on 10-4 here. You're welcome to forward through any of this, but I'm just going to kind of read the question, explain what I did, and where I got my numbers from. An ice cream shop offers 2 types of cones and 15 flavors of ice cream. How many different 2-scoop ice cream cones can a customer order if the same flavor may be repeated? Order does not matter because you will start with the top scoop and the bottom will have longer to melt. So that's Mr. Wang saying that that the order definitely matters. So getting strawberry vanilla is different than getting vanilla strawberry, which, you know, it means you're eating one of them first. I don't know. So it is different. So he's saying he wants it to matter this time. So we have 2 types of cones. There's 15 possible flavors for the first scoop, and there's 15 possible flavors for the second scoop. We don't have to get rid of any repeats, so we're just done. Multiply those out. We talked about number 2 a lot in class, but the basic premise is if you have 5, or I'll go ahead and read it. For Ninja School application, Tomo must choose one of 5 hand weapons and 4 throwing weapons for demonstration. She is allowed to hold up to 5 different weapons at a time. How many different sets of weapons can she choose for the demonstration if she must have at least 1 hand weapon? So that was our friend Lacia figured this out. But if she has to have at least 1 hand weapon, well, there are 4 throwing weapons. That means if she's picking up 5 things, one of them is guaranteed to be a hand weapon no matter what. So we don't even have to consider this last statement. It makes no impact. So for our first pick, we have 9 weapons to choose from. Then there would be 8 left over. Then there'd be 7 left over. Then there'd be 6 left over. Then there'd be 5 left over. Now, in this particular case, the order does not matter. This is a theme you got to get down. We have 5 weapons. It does not matter what order we got them in. So it's easier to think about it with letters. But like if I have the letters A, B, C, D, and E, 5 letters, it doesn't matter how I order them. A, B, C, E, D is still the same 5 letters. It's still the same 5 weapons. So the basic idea is we don't need all of those. We need to get rid of the repeats. So it's how many ways can you organize 5 weapons? Well, that would be 5 times 4 times 3 times 2 times 1. We don't need all of those ways. We just need one of them. So we have to divide off the 5 times 4 times 3 times 2 times 1. Number 3, 8 people entered a pie contest. How many ways can those be awarded? Well, if there's 8 people, in this particular case, getting blue would be different than getting red. Getting first place is different than getting second place. So if I said A, B, C, and then I said B, A, C, those are different. So I don't need to divide off to get rid of those situations where it's the same people, because if the same person gets a different place, it's a different situation. So this is just 8 times 7 times 6. There's 8 people that could get the first one, 7 people left over, then 6 people left over. We talked about number 4, but the idea is it's kind of like a bell curve where there's only one way to roll a 3, there's only one way to roll of 18. As you move in, a 4 and a 17, there's more ways to get there. There's more ways to get there. If you do 3 plus 18 divided by 2, you get 10.5. Right in the middle at 10 and 11 is when you're going to have the most likely results. What is the probability of getting exactly 2 heads with 4 coin tosses? Well, there's 2 things to consider here. First, how many total combinations are there? 2 times 2 times 2 times 2, all of this equals 16. That means there's 16 different outcomes. We want the ones that have exactly 2 heads. Well, we have 4 chances, right? We toss a coin 4 times, 4 chances to get that first head. We have to assume we got it. That would leave us with 2 chances to get the second head. Now, why do we divide by 2 times 1? Because that's to get rid of repeated situations. How many ways can you organize 2 things? Well, 2 ways. So we could organize the 2 wins 2 different ways. So 4 times 3 divided by 2 times 1 gets us 6 results that have 2 heads. You could write it all out and figure it out, but I promise you that's how it works. So 6 out of the 16 possibilities, or 3 out of 8. What is the probability of getting exactly 3 heads with 5 tosses, exact same situation? except we're tossing in an extra time, so it's 32 opportunities. And we have 5 chances to get the first head, 4 chances to get the second heads, and 3 to get the third heads. Now, how many different ways can you organize 3 things? It's 3 times 2 times 1, or 6 ways. So we do 5 times 4 times 3, divided by 3 times 2 times 1, which is 10. So 10 of these have exactly 3 heads out of a total 32, or 5 out of 16. You're choosing 2 sides. This is a really tough situation. They all are. You're choosing 2 side dishes out of 8. Now, my first instinct when I did this problem was to do 8 times 8 divided by 2, because I have 8 choices for the first side, 8 choices for the second side, divided by 2, and that gave me 32 possible situations. But one of those columns of 8, so let's say there's like tater tots, like double tater tots, double mashed potatoes, double okra, I don't know, like there's 8 doubles, not 4 doubles. So we don't want to cut the last group in half. We want all 8 of them. We don't want just 4 of them. So I know that's really hard to consider, but we actually have to pretend at first like the order doesn't matter. So we do 8 times 7 divided by 2. That gets us 28 possibilities. Sorry, the order does matter, but we have to pretend, sorry, I said that wrong. We have to pretend that you cannot repeat your dish. In other words, you have 8 options for the first, 7 for the second, and then we divide by 2 to get rid of the repeats. It's technically divided by 2 times 1. Because how many different ways can you organize your 2 dishes? Well, 2 ways. Either, if it's okra and corn, doesn't matter if it's okra corn or corn okra, no. So there's 28 ways to order, assuming no repeats. But what if you can repeat? We don't want to cut the repeated ones in half, because there are 8 unique repeated situations. I don't know what the dishes are, but like okra, tater, taters, corn, whatever they are, they're each unique. So we did not want to include that in the divided by 2, giving us 36 possible situations. Here, this is just a situation. There's 14 photos. What's the chance that I pick up you or your friend? Well, there's 2 pictures. One's you, one's your friend, out of the 14. So that first time she picks up a photo, there's a 2 in 14 chance she picks up one of those. Well, now that you have to assume she got one. Let's say she got your picture. Well, your friend's picture's still in there, but there's only 13 pictures left. So that's a 1 out of 13. You decide to play the lotto. What's the probability of winning by selecting 6 numbers? It's 1 through 48 inclusive. The order is not important, meaning if you draw a 2, the 2's out of there. You draw a 5, it doesn't matter if it goes 2-5 or 5-2. So those are the same thing as far as the lottery is concerned. So the top, 48, we have 48 balls. We pick one. 47 left over, 46 left over, 45, 44, 43. That's 5 numbers worth. Every time we draw a ball, we don't return it, so you can't get the same number twice. Now, how many different ways can you organize 6 numbers? Well, 6 times 5 times 4 times 3 times 2 times 1. 6 factorial. We have to get rid of any repeats because, like if it's letters, A, B, C, and C, A, B are the same thing. If it was 6 letters, same idea. So we have to get rid of those repeated situations. How many ways can you organize 6 things? Well, it's 6 times 5 times 4 times 3 times 2 times 1. So we have to divide that off. So this is the number of possible outcomes. Well, if we buy 1 ticket, then we have a 1 out of that many. Like we're going to get one of those combinations. So this is our final answer over here. Emmanuel is fronting for Insta. He has 8 different vehicles that he needs to put in a line for a photo. The slingshot and the Jeep must be next to each other. Those 3 cars must be next to each other. So here, we talked about a lot of these in class, but here's the basic premise. You have 1, 2, 3, 4, 5, 6, 7, 8 vehicles. But these 2 are a group. So let's put them in a group. These 3 are in a group. So let's put those 3 in a group. And let's pretend that those are just those 3 take up 1 slot. So this is 1 slot, 2 slots, 3 slots, 4 slots, 5 slots. So effectively, we only have 5 positions we can put vehicles. How many different ways can you organize 5 vehicles? Well, that would be 5, 4, 3, 2, 1. But within this slot, how many different ways can we organize 2 vehicles? Well, that would be 2 times 1. And then within this slot, how many different ways can we organize the 3 vehicles? That'd be 3 times 2 times 1. So at the end of the day, we're multiplying all of that out to get the total number of combinations or arrangements. How many different ways can the letters absolutely be arranged if the 4th letter must be one of the letters of salute? And the 8th letter must be one of the letters of bay. Okay, so I laid out 8 letters, or sorry, eight blanks here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, not 8, 10. I laid out 10 blanks for the word absolutely. So there's 10 spots. I want to look at the most restrictive areas first. That is slot 4 and slot 8. Why 7? Why 7? Why 7? Calm down. There's only 6 letters. I know there's only 6 letters. I get it. But look at the letter L. How many chances do we have to get the letter L? I'm looking real hard. Absolute. Absolute. 2 L's. So even though it's 6 letters, it's 7 opportunities to get one of those 6 letters. So we have 7 opportunities for slot 4. Slot 8, I have 3 different letters, and there's no repeats of any of those, so it's 3 unique. So once I've taken care of slot 4 and 8, how many letters are left over? Well, there'd be 8, 7, 6, 5, 4, 3, 2, 1, basically. So there's 8 letters left over for the first slot. Once you pick that one, now there's 7 left over. Now there's 6 left over. We multiply all those out. Why did I divide by 2? Well, there's 2 L's. So technically, I should have divided by 2 times 1 because I can arrange the L's. How many different ways can I arrange 2 letters? It's 2 times 1. It's 2 different ways. So what if there were 3 L's? We would divide it by 3 times 2 times 1. We would divide by 6, not by 3, which is a common mistake. But since there's only 2 L's, we're dividing by 2 times 1. A resort is ordering new mattresses for those rooms. The rooms with a 3 must have that. The rooms with a 5 must have that. If there are no rooms with a 7, 8, or 9, how many rooms will not have either of the new mattresses? All right. So I just looked at the numbers. So the first digits go from 1 to 5. 1, 2, 3, 4, 5. Well, I can't have 5s or 3s. Look at the numbers I can't have. I can't have 3. I can't have 5, 7, 8, or 9. So 3's out, 5's out. That leaves me with 3 things that can go in front. The next digits can all be 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I can't have 3, I can't have 5, I can't have 7, 8, or 9. That leaves me with 1, 2, 3, 4, 5 numbers for each of those slots. So it'll be 3 times 5 times 5 times 5. We can actually, something very important to point out is we can actually even exclude the number 5,000 because it's gone. But that doesn't have effect on how many there would be still. All right. Next situation. 3 dice are rolled. The first one has 1 orange and 5 blue. So just that die. If I roll it, I have a 1 in 6 chance of getting orange. The second has 2 orange sides and 4 blue. Just that die, I have a 2 out of 6 chance to get orange. The third has 3 orange sides and 3 blue. On that one, I have a 3 out of 6 chance of getting orange. What is the probability that exactly 2 of the 3 come up orange? The only way to get this is to just define those probabilities independently and add them up. So our 3 situations are orange, orange, blue, orange, blue, orange, or blue, orange, orange. I had to figure out each one independently and add them up. 1 out of 6, 2 out of 6, 3 out of 6. That was orange, orange, blue. If the middle one was blue, that would be 1 out of 6, 4 out of 6 to get blue, 3 out of 6, and so on. 5 boys, 4 girls. How many ways can they be arranged if boys and girls are in separate groups? So basically they're in 2 separate groups. How many ways can they be arranged on a bench? Well, there'd be 5 factorial to arrange. Like, how many ways can you arrange the 5 boys? It'd be 5 factorial. How many different ways can you arrange the 4 girls? 4 factorial. And then there's 2 groups. So don't forget that part. How many ways can you arrange the 2 groups? Well, that'd be 2 factorial. And then you have to multiply all those. The exact same situation, but cats, there's 4. Assuming that the arrangement is random, what is the probability that all female kittens are together and all male kittens are together? Now this one's probability. This one's probability. So it's the same idea. How many different ways can you arrange 4? How many different ways can you arrange 4? And then how many ways can you arrange the 2 groups? But it's probability, so how many total arrangements are possible? Well, there's 8 total cats, so how many different ways can you just arrange 8 total cats if it's totally random? That'd be 8 factorial. So it would be your answer divided by 8 factorial. Make sure you reduce. It's going to be 1 out of 35. Chances, if you have 10 songs on your playlist, you hit random shuffle, no repeat, you listen to 2 songs. What is the probability that you listen to your favorite song first and your least favorite song second? Well, if you get your favorite song, you have 1 out of the 10 is your favorite, so you have a 1 out of 10 chance that your favorite song is the first one. Okay, you listen to the first one, it's your favorite, nice. Well, there's 9 songs left over. There's a 1 out of 9 that's your least favorite. You flip a coin 5 times, what's the probability that every result will be tails? Well, you have a 1 in 2 chance every time. So your first flip, you have a 50% chance it's tails. Let's say you get it. You have another 50% chance to get tails. You keep having a 50% chance over and over and over again. So you have to keep multiplying your 50% chance until you end up with a 1 out of 32 chance to get a tails every time, much less likely. 21 students. Teacher sends 4 to the library every day. The teacher will choose the students to go to the library at random. So what are the chances the first day that you will be chosen the first day? Well, there's 4 out of the 21 are going to be picked. If you have not been chosen on days 1 through 3, that means 12 people have been chosen. So 21 minus 12 is 9. So there's still 9 people in the room, and she's going to pick 4. So 4 out of 9. Abigail wants to go on a global trip. So I'm not going to read every word here, but basically there's 4 possible countries when she goes to Europe. There's 6 possible countries when she goes to Asia. 3 possible countries when she goes to South America. So how many different ways can she visit Europe? How many different ways can she visit Asia? How many different ways can she visit South America? Now, it also doesn't say that she'll go to the countries in that order. So how many different ways can she visit the different, not countries, continents? How many different ways can she visit those 3 continents, Europe, Asia, and South America? And that's the overall total number of combinations or arrangements that she could visit these places in. 28% of U.S. medical degrees are conferred to women. Find the probability that 3 randomly selected graduates are men. Well, if 28% are women, then 72% are men. So 72 out of 100 would be your first one. Let's say you get it. Now, the number is so large that even if I take one of them out, it's still going to be 72%. Right? We're not talking about exactly 100. So it's a much larger number. It's going to stay basically 72%. So we're just going to multiply 72% 3 times, which means overall there's a 37% chance that you would get all 3 of them as men, which I believe is what you consider that unlikely to happen. Although there's no real definition for unlikely that I'm aware of. At a particular school with 200 male students, 58 play football, 40 play basketball, 8 play both. Well, if 8 play both, then of the 58, only 50 play just football. And of the 40, only 32 play just basketball, because there's 8 people that are in both of those categories. And then there's the 8 that play both. So overall, we're actually talking about 90 people. What is the probability that a randomly selected male plays neither sport? Well, 90 of them do play one or the other. So 110 don't. That's where the 110 out of 200 comes from. 22, it's just a lot of adding up, guys. There's 31 total shows. The show's a quiz show, or it's on Channel 8. So we have 8 shows on Channel 8. We have 8 quizzes. But 2 of them are repeated. So 8 plus 8 is 16 minus 2. That's 14 unique situations. You don't want to count those 2 twice. You want to count them just once. So basically, another way to think about it is add these up, you get 8. But then when you do quiz shows, just skip over that. You don't want to add the 2 again. So you get 8 plus 6. So it's a 14 out of 31. You do the exact same thing for all 3 of those situations. A parent-teacher committee consisting of 4 people is to be formed from 20 parents and 5 teachers. Find the probability that the committee will consist of these people. Assume that the selection is random. So first thing I did was off to the side over here. There's 25 people, and I'm picking 4 random people. So I have 25 to choose from, 24, 23, 22. There's my 4 people. But it doesn't matter what order I pick them in, right? Like if I have Bob, Sarah, and Susie, it doesn't matter what order they're selected. Bob, Sarah, and Susie are going to be on the list. Well, this is 4 people. How many different ways can you arrange 4 people? We want to divide off all the repeated arrangements. So you can arrange 4 different people 4, 3, 2, 1 ways. So if they're selecting 4 people, there are 12,650 different arrangements or different selections. So it's important to know the total because we're doing probability on this. So what is the probability that they're all teachers? Well, 5, 4, 3, 2, 1. That's how many possible teachers, or there's only 5 teachers to start with. So 5, 4, 3, 2, 1 would be how many teachers there are, or how many different combinations you could pick those teachers, divided by the 1260. But it doesn't matter what order you call those teachers in. So we have to divide off by the 4, 3, 2, 1. And as I'm reading this, I'm asking myself, am I even right? Oh no. If I already got rid of my repeats over here, am I getting rid of am I doubling up on getting rid of repeats? That is a question I'm not entirely sure of. I'm going to think about this for 1 minute, and then if I can't think of an answer, I'm going to move on and assume that I did it right. I actually think I'm wrong. I'm going to put a big question mark by this and give it more thought later. We've already considered repeated situations. So my gut says I should not have considered them again. So I'm going to put an asterisk by it, but I think the answer actually should be 12 over 1265, which means I probably messed up the same thing on all of these because they're all the same situation. But let's keep going. 2 teachers and 2 parents. Yeah, I would have to make a sample space and work this out on a smaller scale to figure this one out. I honestly don't know. 5 times 4 divided by 2 times 1. So again, I did the division. I didn't actually solve this problem, did I? 5 times 4 times 20 times 19 divided by 2 is 1900. Divided by the 12, 650. And that would be 38 out of 253 would be the final answer there. But if I already considered the arrangements, I'm going to put an asterisk by it, but there's a chance the answer is 152 out of 253. But man, that's more than a 50% chance. I'd have to test this one out. I'm going to test this one out later. Sorry, guys. I'm going to skip this section a little bit. I'm not going to keep working them out, but the main idea here is all parents. Well, there's 20 parents. So I figured out how many combinations you could pick the parents in, divided by the total number of combinations. I am not sure if I don't know if this messes it up or not. I'm going to have to make a smaller sample space. Same thing here. One teacher would be 5. You have 5 opportunities to get one teacher. Then 20, 19, 18 for the 3 parents, divided by the total number. I'm going to come back to that another day. The possible combinations for poker, okay, that information actually we don't worry about that too much here. 5 cards are drawn from a standard deck of cards. What's the probability of getting 3 hearts and 2 spades? So you need to know that there are 13 ranks, meaning ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So there's 13 rank of cards, and then there's 4 suits: hearts, diamonds, spades, and clubs. That's information you have to know for the test as well. So if you're getting 3 hearts, 13 of the cards are hearts out of 52. You pick one. Now 12 out of the remaining 51, you pick one. Now 11 out of the remaining 50. So that's my hearts. That's the chances of getting 3 hearts. Well, and then you have 13 out of the remaining 59 and 12 out of the remaining 48 to get the 2 spades, because there'd be 13 spades as well. Multiply those out. 5 cards are drawn from a standard deck. What is the probability of 3 kings and 2 tens? So kings is a rank. We have 4 kings in the deck. We have 4 tens in the deck. So 4 out of the 52, we get a king, 3 left over, 2 left over. Then we try to get our tens. 4 tens, 3 tens. We multiply those out, and we get the chance of getting 3 kings and 2 tens. It's an extremely small chance of getting that exact hand. For the next couple of questions, we need this number. And what that number is how many total ways you can that you could draw 5 cards from a deck of cards. You have 52 cards, you pick one. You have 51 cards, you pick one. You have 50, 49, 48. But we want to get rid of all repeats, because like getting an ace and a king is the same as getting a king and an ace. So like there's how many ways can you arrange those 5 cards? 5, 4, 3, 2, 1. This is the number of possible outcomes if you were to draw 5 random cards from a deck of cards. And we're going to use that on the next 2 problems. Find the probability of drawing a pair. A pair is when 2 cards have the same rank, meaning a pair of tens, 2 tens, a pair of queens, 2 queens, and nothing else. That means none of the other cards match. So the probability of getting a pair, this is kind of confusing, but here's how we have to think about it. There are 13 ranks, and within each rank, there's 4 of each card, right? So how many different ways can you draw 2 cards from the 4? Well, I'll kind of work that out over here if you would like, but we have 4, let's say we're going for tens or something. We have 4 chances to get the 10, and then there would be 3 left over. We're talking about just the 4 tens, okay? But we have to, how many different ways can you organize those 2 cards? Be 2 times 1. So you have 12 divided by 2. So once we know the rank, once we know they're tens, there's 6 ways we could draw 2 tens, right? We have 10 of spades, 10 of clubs, 10 of hearts, 10 of diamonds. There's 6 different combinations there, right? We can pick any of the 4, then there's 3 left over. How many different ways can you organize 2 cards? So there's 6 ways. So there's 13 ranks, and there's 6 ways per rank to get 2 of those cards. So that's the chances of just getting 2 cards, right? Or that's how many ways we can just get the 2 cards. Now we need to figure out how many ways can the other cards not match my first card. This gets a little tricky. Let's say we pick tens. There's 4 of them, right? 4 tens. So even though we just picked 2 of them, we can't pick any more of them. So there's only 48 eligible cards left in the deck that we can pick. Let's say we pick a 9. So this card's a 9. Well, now there's only 44 cards left because we can't get any more 10s. We can't get any more 9s. 8 of the cards are out. There's only 44 cards in the deck that I can pick so that I don't pair up any of my previous cards. I pick like a 7 now. Once I pick a 7, I can't pick any more 7s. So there's only 40 cards left over. And how many different ways can we arrange those 3 cards? Because it doesn't matter what order we get them. There'd be 6 ways, 3 times 2 times 1. So if I multiply all of this out, how many different ways can you get a pair? Well, it's this big number. How many total ways can you get any cards? It's that number we got before. So that is your chance of getting a pair. It's actually really high. The chances of getting a pair, if you have 5 random cards, is pretty high. What is the probability of drawing a straight flush? 5 cards that are all the same suit and in order. So in other words, 2, 3, 4, 5, 6. And they're all the same color, or they're all the same suit. So they're like 2 of heart, 3 of heart, 4 of heart, 5 of heart, 6 of heart, so on. So there's a couple ways you can think about this, but there's 10 different starting letters. I'll kind of make a list, but you could start at ace, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Any of these could be your starting card. Like if you start with ace, you would finish it with 2, 3, 4, 5. That is ace through 5. If you start with 10, you would finish it with jack, queen, king, ace. You can end in ace or start with ace. That's important to know. So there's 10 ways to start it, and there's 4 different colors, or 4 different suits, I should say, not colors. So at the end of the day, there are 40 different straight flushes possible. So out of the entire deck of cards, there's only 40 straight flushes possible. So out of the total number, 40 out of that huge number, that would be your probability of getting a straight flush. Very small chance. As a matter of fact, after you do 1 pair, the rest of them are pretty small chances. How many numbers from that to that do not contain a 5 or a 6? Well, the first digit goes from 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. No 5, no 6. That leaves us with 1, 2, 3, 4, 5, 6, 7 digits to pick from. Now the rest of them all go from 0 to 9. So the rest of them, you would have 8 digits to pick from. But the first one just goes from 1 to 9. And there we go. That's it. So 7 for the first slot, and then 8, 8, 8 for the rest of them. How many odd numbers are there from 3,000 to 9,000 inclusive that do not contain a 4? Well, I actually scratched out the number 9,000 because the number 9,000 is not odd. So it's out. Also, when you're doing these situations, you really want to go, like if you're starting at 3,000, you want to end at, 999. Even if it wasn't asking for odds, I would still do that. like if it was asking for evens, for instance, I would still do what I just did, and then I would actually and then I would actually just add on that last even. But from 3 to 8, right? 3, 4, 5, 6, 7, 8. No 4. There's 1, 2, 3, 4, 5 numbers that fit that criteria. And then the rest of them, 0 through 9, there's 10 numbers, but they can't be a 4. So 9 numbers, 9 numbers. Now, why just 5? From 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No odds, right? Wouldn't odd be determined by the last digit? So it can't end in a 1, a 3, a 5, a 7, or a 9. Those are out. And it can't end in a 4. That leaves me with 1, 2, 3, 4. Uh-oh. Oh, they want odds. I was like, uh-oh, messed this one up. We want the odd numbers. Sorry, no evens. 0, 2, 4, 6, 8. Those are out. I was like, oh gosh, I really did mess this up. No, 1, 3, 5, 7, 9. That's 5 numbers. So we have those 5 numbers at the end. So that's why we did that. Not even messing with number 30. Number 31. This is very similar actually to what we were just talking about, but it's much more difficult. It's 0, 0, 0 to 0, 0, 0. It doesn't have like the odd even restriction. So we can only break it up certain ways. We want to end in 999 or 99. We want to start with 0, 0, end in 99. That's what we want to do. So first thing I did is I broke it down. I went from 50,000 to 89,999. That way, from most of the digits, we don't want to start going into overlap mode. So from 5 to 8, remember there can be no 7 or 8. So if my first digit's 5 going to 8, there's only 2 numbers that I can use, and that's 5 and 8. The rest of them, no 7, no 8, could have 8 possible digits. So from 50,000 to 89,999, there's a bunch of numbers. All right. Then I went to the numbers before 50,000. Again, I'm ending in, sorry, got some, I don't know what's going on. 46,000 to 49,999. I want to go from 000 to 999. So, and plus we got to go back all the way to 46,000. So from 40, the first digit's a 4. There's only one number there. 6 to 9, I can't have 7, I can't have 8. There's only 2 numbers there. And then the rest of them, 8 possible numbers. So now I have gone from 46,000 all the way to 89,999. Well, I'm going to pick up at 90,000, and I got to stop short of 93,000. I do the same process there. 9 is the only digit that can come first. 0, 1, and 2. If I have this digit here, 0, 1, and 2 are my only options. That's 3 numbers. The rest of them, there's 8 opportunities because you can't have a 7 or 8. So there's 8 other numbers. But I got to make it all the way to 93,500. So I'm going to pick it up at 93,000, but I need to end in 99 for this method to work. So I stop at 93,499. And I do the same process. And then that last number, 93,500, is just its own little loner here. And then I added up all those totals. A wizard has cast a spell over Fantasyland where each day there's a 5% chance of rain at some point during the day. What is the probability that you will go 21 days without rain? Well, that means you have a 95% chance not to have rain, and you just multiply that by itself 21 times. Boom. Love you guys.